What's going on, everyone? Homework assignment 47. Today's objective, I can use scale drawings, and we're going to use them to try to solve some problems. All right. So here's our vocabulary. A scale drawing or a scale model is used to represent an object that is too large or too small to be drawn or built at actual size. So one example of this, something that you might see, can be like a blueprint to a house, let's say. We make a blueprint to a house. Obviously, if we're making a blueprint to a house, we're not going to draw the actual size of the house because that's big. It's a very large house, or it's a very large drawing to be made just for a house. Even if it's a very small house, it still doesn't make sense to have a drawing that's that big because blueprints we want to see in front of us. We want to be able to lay down on a table or a desk just so that we can see everything drawn out. Blueprints for a house are drawn up using a certain scale. So scale is determined by the ratio of a given length on a drawing or model to its corresponding length on the actual object, okay? So let's say if we want to scale the right side of a house, then our blueprint would be obviously a much smaller size than the right side of the house, but all of our sides would be proportional to each other. So our corresponding sides would all be proportional to each other. So a possible scale could be that 1 inch is equal to 3 feet, or 1 centimeter is equal to 2 millimeters, just to show different types of scales that we can have. But generally, we like to say, we like to keep our scales down to some simple value, like 1 inch or 1 centimeter. So let's go ahead and let's see if we can determine some scales here. So suppose a model of a dragonfly has a wing length of 4 centimeters. If the length of the insect's actual wing is 6 centimeters, what is the scale of the model? Okay, so here's how we're going to figure this out. I like to write out my ratios, my proportions in words first, just so we can make it clear. So we're going to do just that. So we're going to go model over actual. All right. So my model wing is 4 centimeters. My actual is 6 centimeters. And if I want to figure out the scale, then I will say that it is equal to 1 centimeter. If 1 centimeter is my model, I don't know my actual right now. So we'll say X centimeters. Okay. We're going to use the methods that we use when we solve proportions in order for us to figure out what the actual or what the actual of the of this model is going to be. So just so we can get a nice scale, and I'm choosing 1 centimeter just so that I can scale it down to something a little easy for us, okay? So let's see what the math will bring us to. So we'll have 4x is equal to 6 if I use my cross product. If I divide 4 by both sides, because that's my inverse operation, I will get that x is equal to 6 divided by 4, which is 1.5. So my scale is going to be that 1 centimeter is equal to 1.5 centimeters. All right, and that is my scale, okay? I chose 1. Again, it's really more of an arbitrary pick, but I chose it because it's a nice simple number that we could break it down to, okay? It's easier to use ones, a single unit rather than something else. All right. Let's keep it going. We'll talk about another word here. Another term here is scale factor. It's the ratio of the length on a scale drawing or model to the corresponding length on the real object. Can only be possible if the scale model and the actual have the same units. Okay, if the scale model and the actual model have the same units, that is when it is going to be most possible. All right. All right. So again, we talked about blueprints before. So blueprints of a skateboard ramp shows that its length is 11 inches. If the scale on the blueprint is 1 inch is equal to 6 feet, what is the length of the actual skateboard ramp? Okay, and let's get this to be everything to be the same units. So we can have the blueprint. So here's my words that I'm going to use. Blueprint. Again, I could say model over my actual. Okay, so the blueprint of my ramp is 11 inches. My actual, I don't know yet. All right, but I do know my scale. My scale is going to be that 1 inch is equal to, let me write that one there, is equal to how many inches on the other side? Well, 6 feet. 6 times 12 should be 72. But I'm just going to do the math anyway. Yep. 72 inches. And now we can figure out what the actual length is going to be. So let's do the math here. Ooh. All right. So we will have 11.4 inches, I should say. Let me fix that. 11.4. So we'll have 11.4 times 72, which is 820.8 inches, is equal to x, and x is the actual length. And let's say if we had to find out divided by 12 what this would be in terms of feet, we could say that it is 820.8 inches, or we could say that it is going to be 68.4 feet, okay, or 68.4 feet. And there's another way that we could actually see this done. And the other way that we could see this done is as so. So we said it was 68.4 feet. So remember we said that 1 inch was equal to 6 feet. Well, if 1 inch is equal to 6 feet, then we're saying that it almost has a scale factor, right, of 1 to 6. So what would happen if I multiplied 11.4 times 6? I would end up with 68.4. So in this case, it's almost like that 6 was our scale factor for us, okay? So 2 ways that we could figure it out. One, we can multiply whatever our scale factor is by that model, or we could use our proportion like we saw above in order to solve this problem. So either way, any strategy you can use here works out. We can continue to use this strategy going forward. If you got any questions, jot them down. Check out those practice problems. If you did jot questions down, bring them to class the next day, please, and thank you. I'll see you all then.